Here we're looking at question 13. Here we have f of x is equal to 1/2 x plus 1 plus 3, and we're told to graph it. Okay, so we're going to pick some points here. So I'm going to have x is -1, 0, and 1. Now there's a couple ways to do this. I can either go ahead and just plug in and see what I end up with, or I can adjust it. So for this one, I'm going to adjust it based off the transformations. So to do that, I'm just going to graph this. I'm going to come up with my values here and then adjust those. So if I put in -1 for this, what I'll end up with, now I could write this as 2 to the -1 to the -1, so I end up with 2 to the first power. So that's going to end up being 2 for that. Okay, now if I put in 0 for x, I end up with 1. So I get 1/2, I put in 0, and that's going to give me 1. And then finally, if I have 1, if I put in 1 for the x value, I end up with 1/2. Now, just by looking at this, we can tell it's decay, and so we can see that from our ordered pair here as well. Now, what I'm going to do is adjust it based off of these values. So I'm going to add 3 here because this is moving it up 3. Now, this will have, it'll seem like the opposite effect on it, but this would move it to the left 1 place. So this is the ordered pairs I'm going to graph. So I'm going to end up with -2, -1, and 0. And then I end up with 5, 4, and I'm going to end up with 3.5 for my f of x, or this is our range, and that's our domain. Alright, so over here I'm going to go jot a graph. Now when I do this, I'm going to go back up here with my asymptote. It's going to be y is equal to 3. So I'm going to go up to 3. 1, 2, 3, and I'm going to draw a dashed line there. So that's my asymptote. Now remember, that's where our graph is not going to cross. Okay, now I'm going to plot points. So I'm going to go over to 2, and then I go up to 5. So it'd be somewhere up in here. Then at 1 would be here, and then be at like a half here. And so we just keep coming like this, and then we come up like that. So we've graphed the function. And so now we have a visual of it, and we can kind of talk about some things as well. So the A part asks us for the domain. Domain is all real numbers. X can be anything. Okay, then the range, okay, we're going to get closer and closer to 0, closer and closer to 3. And so our asymptote, our y has to be bigger than our asymptote. So y is greater than 3. Now you may also see it written as y is between 3 and 3, like this. Now, I just want you to be able to see in either way. I'm sorry, not 3, infinity. That wouldn't be much of a graph if it was from 3 to 3. But either one of these is acceptable. Y is between 3 and positive infinity, and here y is greater than 3. These mean the same thing. Alright, so let's look at the B part. B part says increase or decrease, interval of increase or decrease. Now with exponential functions, they're either going to increase or decrease. Well, we're decreasing over the life of this. So what we would say here is that from negative infinity to positive infinity, we're decreasing. Alright, now the C part, we're going to have to go back, and because we want rate of change, and they want it for x's from -1 to 1. Well, this is our real function right here. So we have -1. Well, we need to know what happens when it's 1. So for this particular part, I'm just going to plug back into the original equation. 1/2 to the, I'm putting in 1 plus 1, because again that's x, and I'm just plugging in 1 for that. And then we're going to add 3. So 1 plus 1 gives me 1/2 squared plus 3. Okay, so I'm going to end up with 1/4 plus 3, so I end up with 3 1/4 here. Alright, now rate of change, is going to be our change in y, so it's y2 minus y1 over x2 minus x1. Now, so basically we're finding the slope, but this is not a line, so it's not a constant thing. This rate of change, similar idea. So we're going to use this as x1, this is y1, this is x2, this is y2. Alright, so for y2 we're going to use 3 1/4, okay, minus y1, which was 5. Okay, and then x2, okay, was 1 minus -1. Okay, so we're going to end up with 3/4, 3 1/4. Now you may want to change that to a decimal, but if we do 3/4 minus 5, we end up with negative 1.75. Now again, I just changed this to a decimal, so it's 3. You could use 3.25 minus 5, and you get negative 1.75 over 2. So we divide that by 2, and we end up with negative 0.875. Sorry, this is not 5, it should be 4. Up here, it should have been a 4. So we need to change this. So 3.25 minus 4 gives us negative 0.75. Okay, and we're going to divide that by 2, and now we get negative 0.375 as our rate of change. Okay, but the big thing is it's the change in y's over the change in x for whatever period it is. So that's why we're subtracting. But for this one, for the C part, you should get negative 0.375. All right, now the D part. Now the D asks us for the end behavior. Now we're just going to refer to our graph for the end behavior, and that'll tell us what we need to know. Now if we go up here, as x is going this way, okay, so as x is becoming positive, so as x is going to positive infinity, what's our y's doing? Well, y is getting smaller and smaller, but it will not get smaller than 3, so y is approaching 3 with this. So with this, we would say as x goes to positive infinity, y, or f of x, approaches or goes to 3. Now if you look at the other side, as x is going to negative infinity, so as x is going this way, what's happening to y's? Well, they're getting more and more positive. So we would say as f of x, well, let's go x. As x goes to negative infinity, okay, as x's are getting more and more negative, the y's, or the f of x, is getting more positive. So we'd say it goes to positive infinity. Okay, and so we've kind of answered those.